Question number 16. And just there's the number. The diagram shows a plan of Shivulu's garden ABCD. ABCD. Now, if I just quickly look at this question, I can see equidistance, locus, definitely locus. So let's just go to the textbook. And the first one I want to show you in the textbook is this summary. Okay, let's just see if I found it here. Yes. Okay, this is very important. And then I will show you an example also before we start. So look at this summary, and you will find this summary on page 435 in book 1. It's the end of this chapter. And what was this chapter? This was chapter 8. Okay, now if you look at this, now as soon as you see it's equidistance from a point, so it's a point, okay, equidistance from a line, equidistance from 2 points, or equidistance from 2 lines. That is the different locus. Okay, let's just try to do that better. Okay, I struggle a little bit again with my pen. Doesn't matter. Okay. Now, equidistance, if I stay the same distance, then the loci will be, and can you see, it's going to be that circle. That is going to be the loci. Depending on what they say, 2 meters or 3 meters, but that's the loci. Equidistance from one line, it's 2 parallel lines. So if it's 2 meters, 2 meters, 2. So it's this line and this line to both sides, unless they restrict you to one side. Equidistance from 2 points, then it will be that it's the perpendicular bisector. You will take your compass and then you're going to make more than a half, an arc, put it on that side, make an arc, and where they intersect, you are going to draw your line. And then equidistance from 2 lines, it's bisecting the angle. So put it there, put it there, there, put it there, there, and that is going to be your loci. Can I just say a point? How will they describe? They will either say A, let me just get the pen correct. They will either use this kind of, they will say from A or from B. They just use on one alphabet letter. From a line, they will say from A, B. They will put the 2 alphabet letters next to each other. From 2 points, they will say A and B. So they put an and in between. And from 2 lines, it will be A, B, and then repeating the letter B, C. Okay, and that is the way that they will describe. So that will already give you an idea. So now we are back at the question paper. Question 16. As I said, the diagram shows a plan of Shivulu's garden ABCD. Now let's start with the questions. Using a straight edge, that's just a ruler, and compass only, construct the locus of all the points inside the plan that are 6 centimeters from B. Okay, so I'm going to need a ruler. Okay, so let's just take the ruler. Okay, there's my ruler. And I'm going to need a compass. Okay, now I'm going to just put this on 6. So I put there on 0. Okay, and I'm just making sure that it's on 6. Okay, just can make it a bit bigger. So can you see the point there and 6? I can make it maybe a little bit bigger. Looks a little bit shorter than 6. Okay, now it's a bit bigger than 6, but there is 6. Okay, so I'm going to now, like I'm going to make my constructions in red. So let's just go a bit smaller. So it's from B, so it's a circle. So I'm going to take my compass and I'm going to move it to B. I put it there. Then I'm going to just turn it to that position there. Okay. So make sure that you don't leave a space, that you're really cutting. I'm just checking to see if it's on B. Yes, it's on B. Okay. So now I'm just going to go and I'm going to just draw that. Just find that. Oh, there it came. I'm just going to continue. Sorry. and have it in. Almost like you keep it just in there. And let's just start again. Oh, as soon as I have it, then I leave it. Oh, but there it comes. So make sure you cut that line. There is my first one. Now, the second one, and let's just move it a little bit up that you can see. Equidistance from A and B. Now, where is A and B? There is A and B. I'm still going to use my compass. I'm going to draw the perpendicular bisector. So I'm going to stretch it more than a half. So approximately there a half, just more than a half. So take your compass. And I'm moving it now there. There is my point. And then, as I said, we're just going to, yes, I'm going to stretch it a little bit, put it there. Make it a little bit longer. I'll quickly see now. If I just turn this, just want to see, I think it's a bit more, but if you're unsure, rather just stretch it a little bit more. Okay, so I just make sure it's on that point. Okay, and I move it a little bit down. I'm going to make my construct, it's more like your pencil in green. So let's make a pencil blue. Pencil is blue. Okay, now pen is blue. Let's keep it to green. Okay, so I'm just going to, let's just focus again. Let's just go and make it like that. And then again, I'm just going to get my pen and I just draw. I take this to the other side. To that side, to that corner, B. I do exactly, I just want to turn it first, that it's a bit more there, okay. So again, it must intersect. So rather then just go a little bit back, okay, and then I go to my pen. And I'm moving the incorrect thing. A bit more challenging with my technology, but it's fine. Okay, we're going to succeed now. Okay, so make sure it intersect. Sorry. Undo. Okay, so just make sure, as I said, that it's going to intersect, as I showed you there, and there. Because now I'm going to take my ruler. So my ruler is coming in the picture again. Just want to move it up. There is my ruler. And I'm going to turn my ruler. Okay. And I'm going to put it there and make sure it's on that lines. I must turn until it's on the 2 points where it intersect. You see there. Okay. And I'm going to make the low key red. So red. So I take my ruler. Now this is very important. That is the position for your ruler. But if you draw this line, it must go through the whole inside of this garden. So you can start, that's just the position of your ruler, and you can just put it on that side of the ruler. Sorry, just going to get my pen and put it there on that side. I think I'm too much in the ruler and I'm not at a straight line. Again, as I said, you will not struggle with the same things I am struggling with. Okay, so there's my perpendicular bisector. It don't have to go from there to there. It's incorrect. It must just go through my whole figure. That's very important. Okay, can I just read to you what the memo? The perpendicular of AB with correct arcs. B1 for correct line with no arcs. B1 for correct arc with no line drawn. So they must see that green, that pencil lines also. Then equidistance from BC, okay, let's just go there, BC and CD, and CD. So I think we just move my ruler, come ruler, you just move a little bit out, come compass, you just come in, okay. So it's, can you see which one did they repeat? What letter did they repeat? C. So it's that angle C. So I'm going to bisect that angle. Okay, and again, I'm just going down. And then I'm just going to just quickly get that. Okay, let's just get it there. Okay, there it's in the corner there. I can make it a bit shorter. I think so. It's going to help. Okay, I just want to again go to the corner, make sure it's in that corner. And then I'm just going to the rotating and I'm just going to, okay. And I'm going to make my construct, it's your pencil. Okay. So basically what I'm just doing, and I just want to get it again. I'm just going to intersect and then I'm just rotating to that. You don't have to draw the line through. And I just do exactly the same. I just want to get, come on. Okay. Now you move it. Oh, sorry. You take it and you move it and you put it on the needle on that. And I'm going to rotate it again. Okay. Let's just rotate it. Okay, so okay. Now I just want to make sure. Now sometimes if I'm afraid that it's not going to fit, I'm rather just going to go a little bit wider. It's fine. Okay, they're not going to penalize you for a little bit longer line there. Okay, then I'm doing, and I move it to this one there. And again, it must be rotated. So let's just make sure. Okay. I will now rotate it. I'm just getting my needle correct there. Okay, and then I'm just coming a little bit in. Okay, so let's just see. So again, I'm just going to take that and I'm just going to intersect. Okay, so there's my point of intersection. Do you see that? Okay, and that's the one. So I'm bringing my ruler back again. Okay, where is that ruler? Let's just get it in. Ruler. And the ruler must turn again a little bit. So let's put it on that and the point where it intersects. Okay, I think the best will be to first put it on that point and then to rotate it a little bit to this point. And then it's a bit of moving in, moving out until I'm having that position there. Okay. Okay, that's excellent. Then I take my red and don't forget, you cannot just go, let me just show you. You cannot just go from there to there. It must go through the garden. Okay, so let's just go and I'm just going to make my line again and I'm going to just go through that. Oh, that's excellent. Okay, and I move my ruler away again. Okay, even put my compass away again and I'm just going to quickly check equidistance. Okay, now Lulu plans to plant flowers in the garden. Can I just show? They're just going to check. So everyone is counting. This is the circle was the less. That was just one. But as soon as it comes, they want to see that construction lines. So everyone was then 2, 2. Flowers should be planted closer to B than to A. Can you see? I want to just get my pen there again. Okay, just want to. So closer to B than to A. So they are referring to this area. Do you see? I don't want to color it in, but closer to B. So it's that whole. It's not that side, this side. Okay, let's go on. Closer to CD than to BC. So they are referring to, oh, sorry, this side. Do you see? Okay. So now we must concentrate. It was that, and then it was this side. Okay. And then, and less. Okay. So this will be, can I show you again? This will be more than 6, and the inside will be less than 6. Okay, so where do you think I'm going to, and I'm just going to use another color and my ruler, and we're going to see if I'm going to construct this, because this is the least, but it must be, can you see? It must be closer to CD, so this one is closer. Let's see if all the things are true. Closer than to B than to A, okay? So closer to B, do you see? Closer to B than to A. Okay, can I show you there? Closer to B than to A. So it must be on, so this is closer to B. This is less than 6 and it's more to CD, closer to CD than to BC. And that is going to be your area. So the reasonable attempts A and B. And for that last attempt, which you're going to put there, shade the region where the flowers should be planted. And that will be the region where the flowers should be planted. Okay, so just make sure that all three conditions is true in that area. And I can just repeat, maybe just for the last time. This was closer to B, can you agree, than to A, so it cannot be on this side. It must be less than 6, not more, okay? And it must be closer to CD than to BC. And that is the reason, okay, that you shaded that area. Okay, let's start with question number 17. The quadrilateral ABCD has vertices A, B, C, and D. Find the midpoint of line AB. Okay, so I know this is coordinate geometry. I know in the y equals mx+c, grade 10, 11 book, it will be in chapter 7. And let me just show you an example so that we go there. So 17, let's just see, where did I look at this? This is the easiest formula according to me. So you will find this on page 304, book 1. And it is in coordinate geometry, chapter 7. And there's the formula. Very easy. So you just add your x values, divide 2, add your y values, divide 2. And just be careful of your negative numbers and you get your coordinates. So let's just go back to the question paper again. So if I go back to the question paper, I just want to see, there it is. There it is. Okay, so let's start. That's a very easy one. So just make sure you have the correct points. It's A and B. So if I start, so to get that midpoint, now I prefer to call it x1, y1, x2, y2. Okay, so it's x1 plus x2 divide 2. And then y1 plus y2 divide 2. And if I do that, I could just check. It's going to be 2 plus a negative 6 divide 2. And the y values, that's going to be 3 plus 9 divide 2. Okay. And if I'm going to go, I can even go, now write it now here. I was writing a little bit big. So this is going to be negative 4 over 2, and this is going to be 9, it's going to be 12 over 2. And if I simplify this is going to be negative 2 and 6, as easy as that. And you will get, I think in this case, they're going to give you for the 2 points. So calculate the length of the line. Again, I'm going to just take you, just to refresh your memory, taking you to the textbook 17, and let's see, where did I find that example? I found that example, still the same chapter. It's on page 300. Do you see there? And there is the formula. Can you see the formula? Okay, so basically it's the difference in x value squared plus the difference in y value squared. And because it's coming from Pythagoras theorem, to get that AB, because it was squared, I take the square root. And because it's a length, I can just take the positive option. It's not just an algebraic equation. Okay, it's a practical example. And that's exactly what I did. So don't forget, difference in x squared plus difference difference in y squared, and then you can just simplify. So let's just go back to the question paper. So there is the question paper, and there is my question. And I just move a little bit down. Okay. Calculate the length of AB. Now, don't forget, I'm still at the same points, A and B. So, you see, I already marked it. So, I can just say AB, that's the length, okay? And that is going to be, okay, I'm just going to first write the formula. So, the difference in x squared plus the difference in y squared. And that's going to be, now the difference in x, so what is x2? It's -6. What is x1? It's 2. Okay, and square. What's y2? It's 9. What is y1? And it's 3. And don't forget to square. Okay, and then I'm just going to do, so this is going to be -8 square plus, this is going to be 6 square. And then I'm going to get this as equal to, okay, 64. That's very nice, plus 36, because I know that's the square root of 100, and I know the square root of 100 is 10. Okay, as easy as that. And then line AB is parallel to line CD. Now, if lines are parallel, that you know, then their gradients are equal. If lines are perpendicular, then the gradients are reciprocals with different signs. But this is parallel, so this is very important. I'll take you to an example in the textbook, but this is parallel. Can I just show you? I forgot to tell you there. They give you for the substitution there, and coming to the answer you get there. Okay, but let me first take you to the textbook just to refresh your memory. So it's page 310 that I'm going to take you. And I'm taking you to example 11. Okay. And I'm the page, can you recall the page that I said? 310. I'm still in chapter 7 in its book 1. And I said I'm going to do number 11. So determine the equation of the straight line parallel to this line. So now they give you the line. So they said parallel to this line. Passing, and they give you a point. Okay, so parallel lines gradients are equal. So I just get that gradient value in front of x, and that's 2. And I substitute it. And then after I substitute it, I take that point, and don't forget to make it x1, y1. It doesn't know. You don't have to make it x1, y1. You can just make it xy. There's only one point. And you substitute and you get your value of c. And then at the end, you just put everything into the equation. Now, let's see if that is going to help you. So let's just go back to the question paper. Okay. Now, the first thing is I must say line AB is parallel to CD. Okay, so AB is parallel to CD. Find the equation. So I know because I already worked it out. Did I work it out? No, I did not work it out. I must first work it out. Now, how do I find the gradient? Okay, I think we did it in a previous example also. So let's just find the gradient. To find that gradient, we are just going to say, okay, I just want to take blue. To find the gradient, okay, let's say gradient of AB. Okay, so if I find the gradient of AB, it's m. I think we did it y2 minus y1, x2 minus x1. Okay, so what was A and B? Now, luckily I marked it already there. Can you remember? So let's just put it in there. So y2, okay, it's actually that difference that we're going to get. I'll show you now. I'll make now the connection. So just remember y is on top. So it's 9 minus 3, x2, -6 minus 2. And that 9 minus 3 is going to be 6 over -8. It's that 6 and -8 that you got. Okay, but I think rather, because you can get confused, I think rather just go, and you have it already marked, and just get that gradient. If I simplify it, I'm just going to say now, let me just simplify. So basically, the gradient of AB, and that is going to be -3 over 4. And because they are parallel, therefore, the gradient of MAB equals MCD equals negative 3 over 4. So I already have the gradient. Okay. Now I take any point. You can either take point C or you can take point D. Now let's just look at the points to see which one is better. Oh, you don't have D, so you must use C. You must find still D. Okay, so what is point C? Can I just write point C for you down there? Point C, and that was that, there it is, 1 and 5. 1 and 5. And don't forget, that is X, Y. And now I'm just going to say Y equals mx plus c. So in the place of Y, I put 5. I have m, negative 3 over 4. Don't forget your x. Plus, oh, I forgot. I must put in x. Okay. Let's just do that. Okay. So I put in x. What is my value of x? It's just 1 plus c. Okay, so it's 5 if it goes over 3/4, and it's c. So c is 5 and 3/4. So now I must put everything in the equation, because if I want the equation, so y is equal, there is the gradient, okay, and you can say 5 and 3/4, or you can say 5,75. All is correct. Okay. So make sure, they will definitely give if they see you have the gradient. When you substitute to get that point of C, and when you put everything correctly. Really not so difficult. Okay. And then we look at the final of this question. The equation of the line they gave you BD. The line CD and BD intersect at point D. Find the coordinates of point D. Now, I again have a question paper where I just want you to take 17C, D, 17D, sorry. There it is. Okay, and it's not the whole, it's just part of it that I want to show you. So and it's just this part. And can I just show you what page I am at? It's page 316, number C. Okay, so basically, if they say the coordinate of B, now if I look here, I'm just going to make it a bit bigger. If I say the coordinate of B, I just want to show you the principle. Okay, so if I go, the coordinate, we have the equation of AB. Can I just show you there? We have the equation of AB, and we have the equation of BC. Oh, I hate it when a pen is not, a ruler, its line is not so, it's not that good. Okay, so basically, to find the coordinate, we solve the equations A, B, and BC simultaneously. And so we basically just take that two equations that's forming that vertex, and we solve it simultaneously. And that's what I wanted to show you. And then we will get the one value of x, and we substitute it in one of the equations to get the value of y. So that was on page 316. And we are still busy with coordinate geometry, chapter 7. There you see. But let's go and let's do it. So if we go back there. Okay. So basically, the equation of the line BD is this, and I have the other equation. So let's say BD, that's the equation of the line. That's y is equal to negative 2x minus 3. And I have the equation of the line CD. Let's just write it. CD, and that is y is equal to negative 3 over 4x plus 5 and 3/4. Okay, so basically, can you see they're going to intersect at the point D? So I'm going to solve them simultaneously. So I'm just going to put this in that place of y. So I'm going to get negative 2x minus 3 is equal to negative 3 over 4x plus 5 and 3/4. Now, although this is fractions, because it's exact, I think the best is to just work in terms of fractions. So I'm just going to rewrite it in terms of decimals. So this is negative 0.75. Then you don't going to struggle with the fractions if it's exact. So, and 5 commas, positive 5,75. Okay, so basically I'm just going to take the like terms to the same side. And I'm going to take this to the other side. So let's just start there. So I can, yes, I'm rather going to take now, doesn't matter. I'm taking that 0.75x and it's 5.75 and I'm taking the 3 over, so it's plus 3. So if I'm going to subtract that, I'm going to get negative 1.25 and I'm going to get positive 8.75. I forgot the x. If I divide negative 1.25 and I divide negative 1.25, I get that my value of x is negative 7. And now I'm just going to take the easiest one. Okay, so I'm going to just say y is equal to negative 2. I put that negative 7 in, minus 3, and that is going to be 14 minus 3, and that's going to be 11. So what is the x? Negative 7. What is the y? 11. And that is usually, especially some learners struggle with coordinate, but again I say the more you practice it, the more it's going to grow on you and the more you're going to start to succeed in this chapter or this topic.